Hello, welcome to this video. So this problem will be about a conventional problem in paper 1. So about quadratics, about transformations, as well as circle geometries. So you can see the last part about concyclic stuff, right? So first of all, so in part A, so prove that the graph of y equals fx passes through the point F. Okay, so that would be easy because just one mark. Okay, so part A. So here, we just try to input F4. And then at the end, we need to get 33. Okay, so but here, of course, we need some steps in order to get the result. So first of all, do the substitution first. And then try to simplify the stuff inside. Okay, so 9k and then plus 24k, so that would be 33k. Okay, so and then after that, so that would be plus 33, and then that would be so it's 33. So that's why at the end, so that's why the graph of y equals to fx will passes through point F. So that will be part 1. Okay, part A. And then for part B, the graph of y equals gx is obtained. Okay, so first of all, we have, the coordinates of u. Okay, now, so coordinates of u. So u will be the vertex of y equals gx. So it's no longer y equals fx. So that's why maybe first of all, we need to know, what's gx. Okay, so you can see fx with respect to the y-axis. Then translating the resultant graph, translate upward by 4 unit. So that's why, here we try to summarize a little bit. So B1, so we have fx. And then after the flipping, it will be f negative x, because that's just the horizontal reflection. Just the reflection with respect to the y-axis. Okay, so and then after that, so translate upward by 4 unit. So that's why, so that will be f negative x and then plus 4. Okay, so that's why here for B1, so the first point, so first of all, gx equals f negative x and then plus 4. And then we try to substitute back into the expression. So it will be 1 plus k, and then the square of negative x plus 6k minus 2 times negative x, and then plus 9k plus 25. And then outside we need to plus 4. And of course, in B1 we need to make use of the method of computing square. So that's why we need lots of space here. So first of all, 1 over 1 plus k, so that x squared, and then minus 6k plus 2, 6k minus 2x, and then plus 9k plus 25, and also plus 4. So first of all here, the coefficient of x, will be 6k minus 2, and then half it, that will be 3k minus 1, 3k minus 1. So here we'll try to plus 3k minus 1 all square, and then minus 3k minus 1 all square. Then still within the square bracket stuff. Okay, so and then we just need the first 3 terms. We just need the first 3 terms. And then for the other stuff, so anyway, so we can just maybe we try to simplify this thing first. Okay, so this guy, I mean this. Okay, we try to simplify this first. Okay, so that will becomes, for the first three terms, there will be x minus 3k minus 1. Okay, so that would be the yellow expression. And then for the green expression, okay, so after you try to pick out the negative sign, so there will be negative of 9k squared minus 15k minus 24. Still inside the bracket. Square bracket stuff. Okay, so and then after that, so for the green part, okay, we try to do the factorization. So that will be k plus 1, and then 9k minus 24. And then the k plus 1 finally can cancel. And then, okay, so 1 over 1 plus k is here. And then x minus 3k minus 1 all square. And then minus 9k minus 24, and then plus 4. Okay, so and then finally, so that would be 1 over 1 plus k, and then x minus 3k minus 1 all square, and then plus 28, right? Because minus 24 becomes 28, so plus 28 minus 9k. And then that's why, okay, so u, okay, so from the vertex form, we can directly read, okay, the coordinates of the vertex. And then the coordinates of u. Well, already, okay, I think this part, okay, will be the most tedious part. The most tedious part. Okay, so that will be B1. And then for B2, so find K such that the area passing through F, O, and U is the list. So first of all, we need a diagram. So F, okay, will be here. So F, 433. So somewhere here. So 433. And then we have O. So that will be 0, 0, of course. And then from the last part, U, okay, will be 3k minus 1, 28 minus 9k. Okay, so since k is a positive constant, so maybe we can assume the U, okay, or maybe somewhere here. So somewhere here. Okay, so this is 3k minus 1. 3k minus 1, 28 minus 9k, okay, in this way. So, and then I will have a circle, okay, circle, so circle, okay, passing through these 3 points, okay, but of course, okay, we can have a very big circle, right? We can have a big circle passing through all these 3 points. Okay, so now how to draw a circle? Okay, try how to draw a smaller circle. Okay, with these 3 points there. Now, of course, okay, so you can see we can make use of FO. Okay, if FO, now since F and O are fixed, okay, so U, okay, is a variable point because K, okay, is an unknown. So that's why, okay, we can try to let OF to be the diameter. In that case, we try to have a semicircle. This is a semicircle, and then another semicircle. Right. Okay, so that will be a circle, a smaller circle, passing through these 3 points. So that's why, okay, so first of all, For B2, it's about geometry. So you may try to say, oh, note that OF is a diameter. So in that case, okay, FUO, okay, angle FUO will be 90 degrees. Okay, so that will be like this. Oh, great. Okay, so and then after that, okay, of course, okay, we try to make use of the slope. Okay, the product of the two line segment slopes, okay, will be equal to the -1. So we just try to proceed. 28 minus 9k minus 33 over 3k minus 1. And then minus 4. That's just the stuff. And 28 minus 9k again minus 0 because origins. So 3k minus 1 minus 0. So the product of these two slopes should be equal to -1. And then just calculations. Okay, so just swap it. Then 9k plus 5. And then below, so that will be a negative of 3k minus 1 and 3k minus 5. And then just expand it. Okay, so that will be 19k squared minus 225k and then minus 135 equals 0. And divide both sides by 45. Okay, and then we get 2k squared minus 5k and then minus 3 equals to 0. And after that, okay, so factorization. So k minus 3, 2k plus 1 equals to 0. And then at the end, so k equals 3 or negative 0.5. But don't forget at the top, okay, k is a positive constant, so that's why it's rejected. Okay, so that would be B2. So here comes the last part, so that would be B3. Okay, so from the above, okay, we know that k equals 3, so that's why here, okay, so we have where's G here? Oh, for any positive constant k. Oh yeah, that would be another difficult point. Okay, so here you can see that so y, oops. So you can see y equals fx would always, okay, passes through f. So which is a 433. So and then don't forget, okay, the how we transform, okay, the graph of y equals fx, okay, into y equals gx. So first of all, we try to reflect. Okay, so we try to reflect with respect to the y-axis. So that's why here, so y equals to gx will also passes through the transform point. So first of all, there will be negative of the x coordinate, and then 33, and then translate the stuff upward by 4, so that's why plus 4 here. So and then as a result, so there will be negative 437. Okay, so negative 437, so that will be above, that will be a bit higher, so that's why maybe G, okay, will be somewhere here. Okay, so let E be the vertex of graph of y equals g such that the area is the list. Okay, so that's why here u no longer u, so this y becomes v. And then from part B2, so we know that the area of the circle would be the list when k equals 3. So that's why here we try to plug in k equals 3 here. So 3 times 3, 9, 9 minus 1, 8. And then 28 minus 27, so that will be 1. Okay, so that will be x1, right? But we don't need to know because, okay, we just want to know, oh, would FGOV, okay, really concyclic or not? Okay, now don't forget FOV is already concyclic. FOV is already concyclic, so that's why we have the circle passing through these 3 points, and then the corresponding area is the list. Okay, so now, okay, we just try to, oh, would G, okay, will also be lying on the green circle as well. Okay, so that's why, okay, we just try to use, okay, oh, is this a right angle? If this is a right angle, don't forget FO is a diameter of the circle, then that means FGO would be, if this is 9 degrees, that means our FGO, okay, this angle is angle in semicircle, and HAG, okay, is not really, okay, on outside the circle. Okay, so that's why here we try to consider the product of slope of FG as well as slope of GO. So that's why here, so 37 minus 33 over -4 minus 4. And then times 37 minus 0 over -4 minus 0. And then it throws, so that would 4.625. It's entirely different from -1. So the conclusion is, oh, FGO, this angle is not 90 degrees. So because from B2 angle, FVO is 90 degrees, so G does not lie on the circle. Passing through F, O, and V. So F, G, O, and V are not concyclic. And then finalize the last part, and we end the problem. That's the end of the whole problem. Thank you for watching.